All right, Advanced Math, Trig, Mod 7. Our next learning session here on Thursday, April 2nd. Today's topic is quadratic trig equations. Remember the last 2 days we did linear trig equations. So yes, you're going to need your unit circle out again to refer to and look up some of our answers. And if you look at the 4 problems we're going to attack today, I have a cosine squared, a cosecant squared, another sine squared, and down here, sine squared. They all have squares in them, which are quadratic equations. And in this case, again, since they are trigonometric words, these are quadratic trig equations. And our goal is to just introduce you to solving these problems today. We'll continue with this topic tomorrow on Friday, April 3rd. So for today, top left corner of your paper, 4-2-20. Today's Thursday, April 2nd. Again, the topic, quadratic trig equations. To make this simple, I would divide your paper into 4 parts. And we can do 1 problem in each section. They're all quadratic trig equations, but all solved a little bit differently. You then, of course, will do 4 problems tonight for homework. And this will be due, or that problem assignment will be due tomorrow on Friday, April 3rd by noon. And these 4 problems you'll have tonight will make up your daily grade, okay? Remember, they get graded for completion, yes, but also for proper steps and correct answers. All right, today, let's attack this first problem here. 4 cosine squared of x minus 1 equals 0. Just like yesterday and the day before, our goal is to get the word cosine to be by itself. So if you were going to get the word cosine to end up being isolated by itself, the first thing, of course, you would do is plus over the 1. The 1's would cancel. I've got 4 cosine squared of x equals 1. Divide by the 4, agreed? The 4's would cancel. I've got cosine squared of x equals 1/4. Now, if the squared wasn't there, I would have successfully gotten the word cosine by itself, agreed? Oh, but it says cosine squared of x. That really means cosine x times another cosine of x. So to make the squared disappear, like any other quadratic equation, the opposite of squaring is square rooting. So I'm going to square root both sides, and the cosine of x would equal... Now remember, when you square root a number, you've always got a plus or minus scenario for the answer. So this will be plus or minus. Now careful, do you agree the square root of 1 is 1 and the square root of 4 is 2? So cosine x equals plus or minus 1/2. Now remember, that's not the answer to the question. We still need to go to our unit circle now and try to figure out what the missing angle x is going to be. So really, we're asking, when does cosine equal positive 1/2? And when does cosine equal negative 1/2? Now remember, cosine is always the x-coordinate of all your ordered pairs. So we go to our unit circle, and we pick out all the instances where our x-coordinate is 1/2 or negative 1/2, agreed? And that happens, of course, at what? Pi over 3, at 2 pi over 3, at 4 pi over 3, and finally at 5 pi over 3. So anytime the x-coordinate is either 1/2 or negative 1/2 around our unit circle, those are the answers we're looking for. So it's really all the multiples of pi over 3. So back to my paper. Angle x would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And who would have thunk it? Wow, 4 answers to that question, which we could have predicted. Yesterday on the linear trig equations, we always got 2 answers. Well, now, since it's a quadratic, we get 4 answers instead of 2. Go to problem number 2 here. My goal is to get the word cosecant all by itself. Obviously, I'm going to add over the 2. The 2's would cancel. I have cosecant squared of x equals 2. The opposite of squaring is square rooting both sides. And I end up with cosecant of x equals plus or minus radical 2. Oh, now careful, let's think. That says cosecant, doesn't it? We all know that cosecant is the what? Think with me. The reciprocal of sine. So I'm going to change it to the sine of x, but because it's the reciprocal of cosecant, I'm going to put this radical 2 over 1 and I'm going to flip it over and get 1 over radical 2. Now, of course, you rationalize that, right? You can't have a radical on the bottom. You multiply by radical 2 over radical 2 and we get radical 2 over 2. Now, remember that was a plus or minus scenario. So I'm going to go to my unit circle and I'm going to try to see when is my sine value, when is my y coordinate radical 2 over 2, both positive and negative. Well, if you'll remember on your unit circle, doesn't that happen every 45 degrees around here? My y coordinate is radical 2 over 2 at all of the pi over 4s, right? So my answers, my 4 answers would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 when you look at the 4 values. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, all the pi over 4 values around that unit circle. Okay, 2 for 2 here. There's my answers. Block 3, we've got this equation. Now careful, if you'll remember, on all quadratic equations, every time you see something squared, wasn't your goal to get everything over on one side, get everybody on one side, all the terms, and have it equal to 0? So careful on this one. My first step is to take that sine of x that's on the right and minus him over to the left, giving me sine squared of x minus the sine of x equals 0. Your reaction should be, oh, good, it's now in standard form because all the terms are over on one side. Now notice something, that's sine squared of x and that's the sine of x. They both have a sine of x in common, so I'm going to pull out a GCF of sine of x, right? So if I factor out the sine of x, what's it going to leave me with if I take a sine of x out of him and a sine of x out of that term? Wouldn't it leave me with the sine of x minus 1? Because think about it, if I now distributed, sine times sine gives me sine squared, and sine times 1 gives me sine. And because they're dot connected, I can do the old, let's split those apart and set them both equal to 0 step. So if I separate these and split them apart, I would take the sine of x, set him equal to 0, take the sine of x minus 1 and set him equal to 0. Now here, obviously sine of x is already by itself, but over here I would add over the 1 and get sine of x equals 1. So on my unit circle, when does sine equal 0? When is my y coordinate equal to 0? Well, let's take a look. My y coordinate equals 0 right here at 0 degrees. And where else is my y coordinate equal to 0? Right there at pi. So this yields the answers of 0 and pi. And then I go over here to get, there you go. X equals 0 and pi. Now, when does sine equal 1? Oh, so I'm going to go to my unit circle and figure out when does my y coordinate equal 1? That happens up here, right, at pi over 2, but never again, because notice down here my y coordinate's negative 1 and we only want positive 1. So my other answer is up top at angle x would be pi over 2. So this is a case where there's only 3 correct answers instead of 4. Okay? Finally, our last problem together. Look at this. I could certainly say the same thing I did on the last one. Agreed? Since there's a sine squared, and since that squared term is positive, we want to leave him alone and move everybody over to the left side, get all the terms on the left. So that guy gets subtracted over, and I've got 2 sine squared of x minus 5 sine of x minus 3 equals 0. I minused him over and put things in descending order. Now careful, do you agree that that looks like a trinomial, right? I've got a something squared minus something minus a number. So I am going to factor this, right? I'm going to take this trinomial and factor it. I'm going to math mafia it into 2 binomials. Now, since that says, if that would have said 2x squared, remember, we would have put 2x and 2x. Since it says 2 sine squared of x, we're going to put 2 sine x and 2 sine x. I have a negative at the end, so my signs are what? Different, plus and minus. Now, because there is a number at the beginning, I'm taking 2 times 3, which is what? 6. And I need factors of 6 that are going to add up to negative 5 in the middle. So wouldn't that be a plus 1 and a minus 6? Because a positive 1 and a negative 6, when you combine them, give you the negative 5 that we were seeking in the middle. Now, they're dot connected, correct? So I can do what? Split them apart and set them both equal to 0. So I have 2 sine x plus 1 equals 0. 2 sine x minus 6 equals 0. Here I'm going to minus the 1. Get 2 sine of x equals negative 1. Divide by 2, and I arrive at sine of x equals negative a half. Here I would add over the 6 and get 2 sine x equals 6. Divide by 2 and get sine of x equals 3. Okay, freeze. Remember what we said yesterday? Sine equals 3. Isn't that impossible? Because what was the rule? Sine and cosine can never, ever equal a number bigger than 1. So that yields no solution, correct? The only solution are produced by this part over here. So I go to my unit circle. When is my y coordinate equal to negative a half? Well, let's take a look. My y coordinate equals negative a half right here at 7 pi over 6. And where else? Right here at 11 pi over 6. So my answers to this problem, angle x should be 7 pi over 6 and 11 pi over 6. And I did it. Okay? Introduction to quadratic trig equations. Those 4 problems will now be mimicked on your assignment, which would be these 4 problems right here. Let me put them out here for you. So due tomorrow. So due on Friday, April 3rd, would be these 4 problems here. Number 1, 4 cosine squared of x minus 3 equals 0. Problem number 2 just says secant squared of x minus 2 equals 0. Problem 3, negative cosine of x equals negative cosine squared of x. And finally, the grand finale, number 4, 2 sine squared of x equals 5 plus 9 sine x. That's the one where you'll have to move everything to one side. Try to factor it and get your answers. Those 4 problems. Write the problem, show me the proper steps, circle your final answers. That'll be your daily assignment, your daily grade. Since today is Thursday the 2nd, this is due Friday, April 3rd by noon, and we'll keep the points rolling in that direction, okay? Thanks, guys. We'll see you.